Okay, we can start now. And thank you, friends, for coming, for joining this sharing session. And let me introduce Mr. Duan Jiafei to everyone. So, Jiafei received the highest distinction degree of Bachelor Engineering from School of EEE in NTU, and he's under the A-Star Undergraduate Scholarship in 2021, and also rewarded the National Science PhD Scholarship. And he also worked as a research engineer at I2R for his 1-year research attachment. And also currently he's admitted to the University of Washington, UC Berkeley, and he will be starting his PhD soon this year. So now, Jiafei, I will pass the time to you.
Yeah, thanks, Intia. Let me share my screen. Are you able to see my screen?
Yes.
Can you see the whole screen?
Yeah.
Okay. Okay, so hi everyone. Bonjour. I'm currently not in Singapore. I'm in Paris. So the time zone is a little off. Okay, so I think today my topic that I hope to share at this ARSC is that intelligence emerges through embodiment, and now we are entering a new era of embodied AI. So yeah, I think Intia has given a very comprehensive introduction of myself. In fact, I just graduated recently. I guess you can say recently, last year, June, July. And a lot of the work that I'm going to present in this presentation are not just purely done by me. Also, thanks to my research collaborators from both NTU, A-Star, and other universities around the world. So this will be the outline of my presentation. Please feel free to type any questions that you might have in the chat, and I'll answer accordingly at the end of the presentation. So I think I need to give everyone a background, towards what embodied AI is. I think a lot of the kind of AI that we are, we see in our everyday life, or we see around us, is what we call as the internet AI, which focus on expensive data labeling and very constrained in terms of its training. And a lot of this type of internet AI actually focus on data that comes from an egocentric point of view, whereas what embodied AI is doing is that it focuses on learning through its interaction with the environment, which I'll explain what's the difference between embodied AI and reinforcement learning. And it comes from more of an egocentric point of view. This is to actually helps to bridge the gap of data constraints, and even providing this type of simulation environment for people to collect a limitedness or infinite amount of data in a very cheap and affordable way. So I always like to summarize what embodied AI is really about through this quote. Highly recommend everyone and anyone that's interested in the field of the area of embodied AI to actually read that on this paper. Is called The Development of Embodied Cognition: 6 Lessons We Can Learn from Babies. So the idea is that embodiment hypothesis is the idea where intelligence emerges really through the interaction of the agent with its environment, and as a result of our sensorial motor activity. So this comes from more of a cognitive science perspective, but it can be clearly and easily relate to people in the field of machine learning. So yeah, so if you didn't get what I said previously about what embodied AI is, just to summarize it again, it's egocentric perception plus interaction in a virtual environment, and this environment can later be deployed into the real world. So this actually helps to make machine learning much cheaper, scalable, safe, and reliable. And we also want such agent that learns in embodied AI settings to exhibit human-like traits. That's why it comes from the egocentric view. So it allows for more of an active perception, long-term task planning, and learning by interaction. And as clearly we can see, there is a rising trend. In fact, Facebook is investing millions of dollars into metaverse, and a huge portion of the metaverse effort is actually built upon the work of habitat scene, which is a simulator that will cover in the later part of this presentation. And there is a growing trend in terms of the number of papers being published in the area of embodied AI and coming out from these simulations that the embodied AI community actually have. So I think the motivation has been very clear to this point. It's really to help to build AI that's safe, trust, reliable, and comfortable for humans. And you can actually see how it actually integrates into, some of the real-world applications like AR, VR assistant that has a knowledge of its surrounding and is able to navigate in the real world in a safely and reliable manner. So I will talk about the first part, which is the simulator. So the simulator is a key component of embodied AI. Unlike reinforcement learning simulator, which is purely game-based and has a implicit reward setting whereby the agent really learns and gets feedback from the environment and is being rewarded and sort of updates its policy from there. Embodied AI simulator is more of an open world concept. It helps to replicate a potential real-world environment, allows for controllable artificial agent with actionable controls. It must have physics engines with realistic physics, and most of them are built on a 3D game engine and a programmable language framework. So whatever I'm going to cover in this simulation followed by the task, you can actually find more detail about it in a survey paper that was written by us that was also accepted to the one of the IEEE journals. So here are all of the simulators in the field of embodied AI. As of now, there's currently about 9 to 10 simulators out there. I'll go through with everyone. Okay, so these are just some of the ways that we actually look at these simulators and try to benchmark them accordingly. So I think this is actually proposed by the survey paper itself also. We benchmark them based on environment, whether are they more of a game-based or world-based. So game-based, you will expect something that's less photorealistic, but it has more functionality. Whereas compared to a world-based that most likely comes from a scan or a neural rendering technique of the environment. And physics, we also look into like whether does it have basic physics, which is collision, fall, containment, to advanced physics like particle physics, cloud physics, and soft body physics. And we also look into the object types and how are these environments being built. Are they more of a data set driven environment whereby they have extract their 3D objects from a data set, or is it an object asset driven whereby they harness it from an open source from online? And looking from the point of object types, we need to know what is the properties of the interactable objects. Are they able to have multi-states or single states? And how are we going to control it? Is it through a direct API, a VR headset, or even through a raw system? And because of the controller, it narrows down to its actions in terms of atomic actions, in terms of there's a moment. Yeah. In terms of its atomic actions, in terms of whether is it more of a human-computer interaction, and also lastly, we look into multi-agent. Is it more of an avatar, self-driven avatar, or is it a user-based whereby you can actually control and take over the avatar in the virtual world? So I'll go through all the simulators to give everyone a quick summary of what are out there, and how can they actually be suitable for any of your projects that you're looking to do in the field of embodied AI, and how can you select a simulator in a better way. So the first simulator is actually a very early iteration. It comes from DeepMind. So it's called the DeepMind Lab. The idea is that it's an environment for navigation tasks, tasks for food collections, or even movements, and it allows for some form of agent-to-agent laser tag. So you can actually see this is more of a very fine line between what an embodied AI simulator might be compared to a traditional reinforcement learning environment. Over the years, there are more and more improved simulators such as this, which is AI2Tor, which was developed by the Allen Institute of Artificial Intelligence that is based in Seattle, Washington. And it comprises of about 120 rooms of 4 room categories. It has excellent Python APIs. It supports multi-agent. It allows for interactable, object classes. So, if, for example, if you have an apple and you decided to, slice the apple will actually change its shape. So that's what I mean by interactable. And it also provides more for extension towards Robotor, which is a robotics version of it, with inbuilt ROS, and manipulation Tor, which allows for fine-grained manipulation in terms of pickup. And also there's an iteration called a gesture Tor, which allows a VR integration into the system of AI2Tor. Yeah, then next we have Charlotte. Charlotte is a room that was built by Cornell. Is about 58 rooms that's into 10 different houses with 150 objects, with Python API, pretty similar to what AI2Tor offers. Maybe less on the infrastructure support because Allen Institute is quite a huge organization. And there is also Virtual Home by MIT. MIT CCL. So Virtual Home is a bit different. It actually is the first humanoid or avatar-based embodied AI simulator, whereby it focuses on having these avatars that sort of looks like humans and are able to perform basic gesture actions like human, unlike the previous ones which I mentioned that uses more of a robotic system. Virtual Home also have its own data set, which is a program script of all the household tasks. And he uses, that's what I mentioned about object types, which comes from a data set, which they use the SunCG data set, which comprises a huge array of 3D objects, furnitures. And next we have VR Kitchen. VR Kitchen is by Sun Chunzhu's group in UCLA. Is a more interesting avatar-based simulator, which has a fully interactable kitchen setting. It also allows I think one of the first ones that actually allowed for VR integration. That means you can actually wear a VR headset and operate the avatar from a first-person point of view. Yeah, so also to mention one point is that a lot of this avatar actually learns or provides feedback in the form of an egocentric view. So you learn directly on the RGB. Although some of them provides you with more visual modalities, which I'll cover a bit later. Yeah, so this is what I mean by interactable, which you can see very fine-grained interaction as the person slicing the apple. Okay, then next we have Habitat. Habitat is actually one of the larger ones that is being maintained by now I think they call it Meta. Habitat actually is one of the more unique simulator, which it allows you to render it on different environments dataset. So environment dataset can be like Metaport 3D, Gibson V1. So Metaport 3D is actually a 3D scan dataset of multiple real world rooms using the idea of more towards photogrammetry, and this allows you to and Habitat Sync allows you to integrate the AI agent into such scan environment and controlling it, and having the kind of feedback that you were supposed to get in a regular kind of simulator. However, one of the downside about Habitat Sync is that it doesn't have a lot of interactable object. As you can see that the mesh is actually combined together with the room, but it's actually good for learning indoor navigation as close as possible to the real room. And next we have Gibson. Gibson is by Li Feifei's group in Stanford. Gibson is actually very similar to, I would say it's very similar to Habitat. However, they sort of try to bridge the gap of having the object mesh be able to be interactable. So as you can see that even though it's a scan, but some part of this scan is sort of being annotated in a way that it allows you to actually interact with the object. And Sapien is another simulator that is a bit more unique. It utilizes the PartNet dataset. So if for those who are not very familiar with the partner dataset is actually a collection of 3D objects that they actually annotate the different joints and different parts of the object itself and segment it out. So that allows for more fine-grained manipulation for robots. And this actually also, the CPM dataset also provides with a ROS controller for the robotics agent. And last but not least, we have the 3D World. So 3D World is a dataset also from MIT, but I think this one focuses a bit different. It focuses a lot on the high-level physics simulation, which is like cloth, soft body, fluids, and it provides a Python API and a VR-based API. Okay, so after talking about the simulator, I think a lot of you can have a very clear idea how a simulator, an embodied AI simulator is built. But you have to build in an open world concept, and most of them, is wrapped in this layer in terms of its architecture. So it starts with a 3D game engine. You can use a Unity or Unreal. So some of the simulator I mentioned just now uses Unreal, some of them uses Unity. You wrap it around with a Python API or a VR API. And of course, you want to have integration of the different machine learning libraries from Torch or TensorFlow, and you can use that to actually generate those reward feedback that you're looking for in regular reinforcement learning problem. So our group also built one of the Embodied AI simulator that will be coming out soon. We're still currently in progress. So this is an Embodied AI simulator for babies. So the idea of that baby is one of the best learning agents in the world. So hopefully we try to mimic, from the baby point of view in terms of learning and how it can help with like continuous learning, even in terms of curriculum-based learning. So yeah, stay tuned to this work. And okay, so after I talk about all the simulators, you have to compare them based on their specification in terms of what is some of the specification, in terms of their room configuration, the kind of simulation engine that they are running on. It depends on whether how realistic are you looking at. Of course, Unreal Engine 4 is one of the more realistic ones, but Unity has more functionalities, which allows user to tweak around with the simulator. And you want to look into technical specs because while training them, you need to know whether do you even have enough GPU to actually run them. So these are some of the things to take note. Of course, you can refer to my survey paper and find out more about all this information. And one more thing to mention, most of these simulators have these 5 things, which is the visual and audio attributes. So visual can be in terms of RGB, depth, instance segmentation, class segmentation, because of all the ground truth that it has, and even some kind of audio ground truth that's been provided by the creators of these simulators. So yeah, this is just a visualization of what I mentioned in terms of the different kind of embodied AI simulators that's been covered. So as a result of this simulator, as I mentioned, Era of Embodied AI is to provide a form of ways for you to collect an unlimited amount of data for learning if you're not talking about reinforcement learning approach. So for more of a supervised and unsupervised, you want to collect data set from this environment. So as a result, it gave birth to a few data sets, such as VR Chef, Virtual Home has its own program script data set for visual language. Alpha is a visual language data set, and also ActionNet is also one of the visual language data set that's out there. So I will be presenting on ActionNet, which is my work during my undergraduate days. So what ActionNet is in terms of this framework that summarizes everything. But to break it into a simple context is that what we do is that we wrap around AI tutor and provided this GUI platform that allows the annotators to interact with the AI tutor environment in real time to actually perform a specific task that's given to them, and every actions that they take, every step that they take helps to formulate towards that data set of a task-based data set. So this task-based data set can be later used on training for long-term sequence planning, or even uses for visual language navigations. So as you can see, this is how the platform looks like. And as a result, we have collected over 64 different tasks, household tasks, in fact, that is across the 120 rooms. And with the data set, okay, so this is what example of the data point of the data set will look like of a single task. And as a result of that, we are able to segment them into different levels. So it goes from the atomic level in terms of every single actions that the agent takes to the higher level whereby it sort of segment them based on a sequence of different tasks. So for example, finding the butter knife, slicing the bread, which is a general secondary level, putting the plate down. And all these will actually build up into a higher level, which is the final task. In this case, is to toast a bread. And of course, we also provide the visual data, the visual ground truth for anyone that is interested to use this data set to train their agent. Then one of the another contribution that we actually provide is that in machine learning, especially in supervised and unsupervised learning, the amount of data you need is actually quite huge in order for you to have a very decent training process. So unlike what traditional computer vision teach you about data augmentation, which you rotate the image, we we come up with a way to actually augment the data in a very interesting way to provide 50-fold increase in terms of the data size. So how do we augment it? So we use the general structure of how a task is formulated, and we transfer it into a totally different room. So as you can see on the right, there is the task being collected, which is to remove all the object from the fridge, and the steps, the hierarchical structure of the task that's been generated was fed in the different room, a completely different room, and yet the agent can still perform this task. I think this works based on the underlying intuition that humans does not differ too much when we are performing a task, even though if you're in a different environment. Don't believe me, you go try it out. You want to do a task of slicing a bread. If I throw into someone's house, a different kitchen, sorry, you are still able to perform the same task. It's just that it will be slightly different, but the general idea is the same. Okay, sorry, next slide. Yeah. So as a result of these simulators, it also give rise to a various range of embodied AI research tasks. So in general, we classified the tasks into these 3 task categories: visual exploration, visual navigation, and embodied QA. So the methods wise, you can actually refer to my survey paper for more details on the fine-grained methods and what are the publications, what are the simulators that's being used, and even their metrics. So I'll go through each categories one by one so that everyone has a better idea of what is on this task. So I think the embodied AI research task, the first one is visual exploration. So visual exploration, unlike yes, you can do it in the real world using robotics, using LiDAR and whatever, implement somehow robotics algorithm to do that. But for embodied AI simulator, you want it to deploy in a simulation environment so that you can cut down on the cost of training in the real world and increase the efficiency. So as a result, actually there is a few methods being proposed. One of them is curiosity. Okay, so before that, what is visual exploration? Visual exploration is the agent will explore freely of the environment so that it learns new knowledge, and using this new learned knowledge actually will help with more downstream tasks such as visual navigation and embodied QA. So for visual exploration wise, there's about 3 approach: curiosity-driven approach, coverage approach, which focus on covering as much area as possible, and even a reconstruction approach, which aims to reconstruct the given inputs that's provided to them. Okay, next. So next is that after visual exploration, the next step is the downstream task is visual navigation. So unlike traditional robotics approach, which either uses mapping, localization, or planning, or if you are in between localization and mapping is SLAM, and between localization and planning is active localization, or even between mapping and planning is exploration. So unlike all these, I think the embodied AI one uses more of a direct visual input and learns directly from the first point of view, and doesn't rely on any other sensorial data that can be captured using LiDAR or whatever. Although it doesn't mean that it doesn't have, but it's just that you try not to use it. So as a result, for embodied visual navigation, this actually is one entire track on its own in this year's ECCV. It focused on about 4 categories. These are just some of the general categories. So it focused on point navigation, which the agent is tasked to navigate to any position within a certain distance from its initial point. Or object navigation, whereby the agent is supposed to navigate to an object that is specified by its label. It can be also be in an unexplored environment. And navigation requires the agent utilizes a semantic knowledge or prior knowledge. It can be a scene graph, for example, as a form of multimodality inputs to actually aid the navigation in any unseen environment. And lastly is vision navigation, vision and language navigation, or VLN. The agent learns to navigate the environment by following natural language instruction. So this actually is a lot about the natural language, vision language grounding techniques. And the last category of research tasks actually focus on embodied QA. So traditional QA has been there for quite some time from language-wise. It started from Stanford datasets. So building towards what embodied QA really represents is that it focuses on asking questions that's relative to the environment, and the environment can change because of the dynamics of the interaction. So for example, you can be asking how many apples are there in the room, so that the agent has to have some form of memory system to actually remembers what he has observed. And it can be other questions such as what's the color of the car and things along that line. So these are some of the tasks that Embodied AI actually captures. And usually for Embodied AI, for Embodied QA, it runs on a framework that you see on the right, which starts with an input layer together with the QA questions. And it goes into, of course, the QA question has to be tailored to the environment itself. So it's a data set on its own. And you execute into a planner, and the planner will be able to go through semantic memories and go through the low-level controls and followed by the output. So to connect all the dots together, so this is what you expect to see when you connect the simulator to the task and to the data set that's provided by the community itself. And I think some of the standing challenges that Embodied AI still face in terms of research, and that can be a good point for entry for anyone that's interested in the field, is that there is a lack of standardization for simulators. We are not going to lie about that. Everyone has their own simulators. We try to find a way to integrate and work in a collaborative sense, but it would be good that if we can standardize all the simulators, that will help a lot in terms of benchmarking. Sim to real, so sim to real in a sense whereby if you look at really how AI boom, one of the huge contribution or one of the huge significant milestones is actually ImageNet. So there isn't really such a 3D data set that is big enough to, in a comparable sense as compared to ImageNet as of now. Although there is a lot of large models that's coming out in the recent years. And next is the low performance for very complex tasks such as VLN. So low performance as in it can be below like 40% accuracy, 40 to 30% accuracy, which is not good enough, into the real world. In the real world context, that's actually considered if the agent has failed in the task. But because of how complex the task is considered quite well. Good memory representation, which is important for all the embodied AI tasks. Fine-grained interaction, I think that is something very important, and how to actually have fine-grained interaction in a very photorealistic environment. That's something that's interesting to look into. Human actions model and low performance in general with realistic sensors and data set itself. So I think even though like AI tutor has 120 rooms, I think that's still far not enough in terms of training large scale models. Today's context. Okay, so I think I have come to the end of my presentation on what you call that, on the topic of embodied AI. So anyone has any questions, please feel free to type in the chat, or you can ask me later. And I will encourage anyone that's interested to check out our survey paper. I think the next portion I would like to use this to actually talk about CS and AI applications for anyone that is interested to apply for a PhD in computer science or in AI. So as I myself actually went through this entire process, I realized that there's much more things, and I wish that someone could have told me this at the start of my application journey. So I think one of the inside jokes in CS application is that you need a PhD to do a PhD. At least it's true to some degree. So this is the stats of one of the university that I applied to, which has accepted is University of Washington. So under the Paul Allen School of Computer Science. So in this year's application alone, there's 2,500 applicants. And of that, they only admitted 50 people. So that's just nice over 2% in terms of admission. So that's how competitive, getting the CS PhD program overseas looks like. And here there's more statistics that actually back my claim in terms of how competitive CS PhD actually looks like, and why is it important for anyone here that is interested to do a PhD in computer science and AI to start early is essentially. And of course, these are just some of the statistics, some of the grading system based on statistics that are obtained from CS ranking and other ranking platforms. And do bear in mind that actually if you're applying for a PhD program, do not look into those ranking that's used for undergrad. It's not going to be accurate. So one good gauge is to actually look at their publication and their impact factor in terms of that's coming out from these schools. So I think the tier 1 schools are quite obvious. It's the top 4. The big 4, sorry. So CMU, Stanford, MIT, and Berkeley. And there will follow up, there will be the tier 1.5 tier, which is considered still quite good schools for computer science. Washington, San Diego, Cornell, Tsinghua, ETH, UIUC, and Michigan, and even UCLA. So I'll be sharing from some of the tips I'll be sharing comes from my personal experience in terms of my admission process, and hopefully it can help anyone that's applying for PhD this year. Of course, take it with a pinch of salt. Yeah, so just to summarize, whatever the tick that you see here are the schools that I was admitted to in this cycle. So of course, there's other schools which is not under the top tier 1.5, which I didn't mention here. So I think for anyone that's interested in applying for PhD, I think this is the expected timeline that you're going to work with, which is not much time actually, if you look at it at this point in time. So August, you want to start to find the level of interest, prepare your application, your GRE, write a personal statement, contact your referees, and prepare your applications further, get some kind of good recommendations, and try to work out some publication along the way. And the deadline usually ranges in terms of mid-November to end December, which is usually for CS is until 15th December. And there will be the waiting period, there will be selections, interviews. Some schools doesn't really have interviews. So for CMU, it doesn't really have an interview. It straight away selects and announce the result. Then for CS wise, after the interview, there will be open house visit, which highly recommend anyone that's applying for PhD and you have multiple options, we need to go for the open house visit. So I did a flying visit to US to actually check out all these schools. So this will help you to have a better gauge what is the best school to actually to join based on your personality, based on your research style. And of course, to make your decision and at the end of the day, prepare yourself to go to the US or go to wherever it is. Yeah. So I think to just summarize what's the things that is being evaluated for application for a CS grad school, I think GPA is definitely one of them. Some schools actually focus more significantly on GPA, which I cover a bit more later. Letter recommendation, you need at least 3 letter recommendation, your research statement of purpose, publications, and other factors such as connection, luck, GRE, and TOEFL. So I think to go more in depth into this, GPA. So in Europe and UK, they require you to have at least a first class honors. due to the lack of a master degree. But if you do have a master degree, then this doesn't really apply. And for US wise, if you're looking into applying for tier 1 schools, this is the required GPA, and tier 1.5, tier 2. So these are all based on past statistics. Then letter of recommendation, at least have 3 letter of recommendation, and try to ensure that your 3 letter of recommendation doesn't have any overlap points. So you might want to discuss with your referee in terms of what they want to cover and talk about in the letter of recommendation. So what do I mean by overlap means that, if your recommender, the referee number 8 talks about your academic achievement, your referee number 2 might want to talk about your publications, and referee number 3 will talk about something else. And of course, it's best to get overseas profs letter of recommendation, because they are more they are more well known in their own circle. And try to keep the letter of recommendation coverage mainly under your achievement and your work ethics, and not so much about your other your leadership skills and all this. I mean, grad school they do care, but not that significant. Research statement of purpose. Some UK schools actually require you to write a very comprehensive research statement of purpose. Try to get multiple people to vet through your statement of purpose, cover all the past research that you have done, the paper that you've published, provide a clear path towards your PhD, convince them why you are ready for PhD. And and that would be good in terms of for your research statement of purpose. And also, is usually the research statement of purpose is kept to a certain number of pages, so you might want to write down things that's really important that they actually look into. And I think the last point, some people might debate whether is it very important, but I will say that it's quite significant to at least have 2 top-tier papers, as a first author. And this will be useful for your admission process. So top tier, of course, I mean by New Reefs, ICRA, ICML, AAAI, for computer vision and other areas. These are some of the conference. You really boost your chance quite significantly in terms of your application. You don't need to have a lot, but you need to have at least a few. So the reason is because this is the best way for you to show to the admission committee that you have your stuff. I mean, there's no other ways for them to evaluate a candidate besides seeing their actual work being published. So this would be actually good to have. Although some may say that you don't really need that, but I would say that it is important, because I know quite a number of people that are rejected or not even having, like, maybe only have 1 offers because of lack of publications. Yeah, and the last one is, as much as possible, collaborate with faculties that you would like to apply to early in your undergrad years. GRE is something that's good to have, but now I think a lot of schools is slowly removing GRE. When I'm applying, I think because of COVID, they didn't really care about GRE. TOEFL, if you are Singaporean who grew up in Singapore, most schools doesn't require you to have TOEFL, but be careful. Some schools actually do require you to have TOEFL, because to them, Singapore's native language is not English. Singapore's native language is the 4th language. So that actually matters a lot. And lastly, if you don't really get into the schools that you really desire, don't be stressed out, because luck actually plays a huge role in terms of the admission. So I do know people that only get into one school, which is good school, and fill in all the other admission that they apply to. And after you are done with this, they extend the offer to you. So the next thing is, they throw the ball to you, is for you to catch the ball and make a decision. So you have to decide. I think one of the 4 gauge to actually decide which school to go to will be faculty, research group, culture, cities and locations, which matters a lot in terms of, you're going to stay there for 5 years. And lastly, how are you going to get your funding? So so I will, if anyone is interested, I'll talk about this in a later, if there's other opportunities that will cover these 4 areas. So with that, I've come to the end of my presentation and open up to any questions.
Okay, thank you, Jiafei. And I think we already have 2 questions coming in. So one of them is about the previous sharing on Embodied AI. Say, if embodied AI is applied to robotics, will there be challenges if simulated environment, maybe physics interaction is not real enough for the robots?
Yeah, I saw the question. So if okay, so I think of course real world physics and simulation physics, there is still going to be a gap. So that is something that is inevitable at this point in time. But I would say that this gap from sim to real is slowly being bridged in a way. That means there are people that's working in areas of how to bridge the gap between sim to real. So that's a whole new area on its own. It can be bridged through injecting noise into its learning and to sort of mimic the real world noise. Noise, when I say noise, I don't mean like noisy sound or whatever. It means that noisy signal that goes into a sensor. So these are ways that people are trying to bridge that gap. So I wouldn't think that it will be a problem. I think that it's just another area that people are pushing towards that frontier, trying to bridge that gap. Yeah.
Okay, thank you. And another question is about PhD, I think. Does previous rejects affect future application for PhD?
Okay, that's a very good question. I will say that if you apply a few times, it doesn't affect your future application, but what it affects is that every year as you apply again, the kind of expectation that they have on you becomes exponential. So what do I mean by that? So if on the first year, let's say you just finish your undergrad and you apply for a CS PhD, maybe they expect you to have at least one to two top tier. That's pretty much about it. But when you go to second year, it's not going to be, they expect you to have two top tier. They might expect you to have like 3 to 5. So the expectation becomes more exponential as the longer you delay your admission or delay because of rejection. So it doesn't affect the same application process. So they're not going to say that, oh, he failed last time around. But it does matter because they look at that. So why I say it's exponential? Because they will look at your previous application and they'll look at this application. What's the difference? Have you made any improvements? Do you make any changes? Things along that line. Yeah.
Okay, thank you. And friends, if you have any other questions, you can just post in Q&A or in the chat. We still got some time. Yeah, so feel free to ask questions. Okay, one question coming in. What's the current stage for the target-driven visual navigation?
Okay, let me try to understand this question. So what is the current stage for the target-driven navigation? So I think for the current stage of target-driven navigation is people are actively coming out with new models to try to beat the state of the art in terms of this area. I think the current stage will be that there is going to be a shift in terms of what visual navigation looks like, and there will be more focus on visual language navigation. And how this focus actually transcends into the real world is through those large language models, large visual language model, or can be large language model on its own. And those can be later used into like robotics. So there is a work that actually came out, I think recently, by Google. It's called SayCan. So I recommend anyone that's interested to know what is the current state of visual navigation to actually look into this work itself. So this is the ideal work of how language grounding plays a role in terms of visual navigation. Yeah.
Okay, thank you. And
but to answer that in simpleton, you can't really say specifically which one is what's the current state, because as I said, there's multiple simulators. Some people have a better result scoring on simulator A, or some teams has a better result scoring simulator B. But in general, I would say that the accuracy is not like like a hardcore what I call it, like YOLO that is like 90+% accuracy on ImageNet. So it's still below a rate that it doesn't perform as much as very significantly better or even to a level of human. Yeah.
Okay, thank you. And if you have any other question, you can post it, and we still got a few more minutes. So let's wait until 55. If there's no other question, then we can call it an end.
Yeah. If anyone has any question about grad school application in general, can also feel free to ask in the chat.
Actually, a question from me. So, how do you see the gap year when you are preparing for a PhD application? Like, yeah.
So you mean like taking a gap year, or like for my case, I'm doing a research attachment? I mean, I'm doing a research attachment as part of a scholarship requirement. But I mean, for people that wants to take a gap year, I would say that if you are taking a gap year just to do PhD application, I think that is not the right approach, because what are you going to do in that 1 year? That's the thing. If you're just going to do nothing, then that will be an issue. I mean, one way to put it in a way that if you really you're serious about applying for PhD and you feel that at this point in time, you doesn't have the meat to actually, submit the application and get a chance to be accepted, and not, waste your application fee, because the application fee is not cheap. I would say that, find a research attachment. Not necessary to be in Singapore. You can find it overseas. Try to work as close as possible to the potential lab that you want to join in the future. Because as much as people are saying that, it's community-based admission, but connection do matters. Yeah. And who you publish the paper with also matters.
Okay. Thank you.
Yeah, so I think one way to put it is like, you can publish a tier 1 paper, but in a tier 1 paper, all the authors are people that you don't know, or that's not well known, compared to publishing a tier 2 paper that you have one very significant author that is inside that paper.
Okay, understand. And friends, if you have another question, you can post in the chat or Q&A session. Another question coming in, so this SayCan project is basically a way for a robot to interpret a request and figure out a list of things to do in response.
Yeah, so I think if you look at, so basically, okay, if you are interested in Embodied AI, take a look at what ActionNet is doing, look at what Alpha is doing. Alpha is basically a data set that allows, that provides task-based of like, different tasks with its atomic actions. And the agent will learn to do new tasks in that way. So basically, SayCan is a project that sort of, bring what Alpha and ActionNet is trying to propose into the real world. Yeah, into a real world environment. So, given a task, it can be a new task, whatever task is in this environment, can the robot make correct decision to select from a list of, pre-trained response to actually carry out the interaction with humans that makes sense. Yeah. So for example, if you ask a robot, go, make me a cup of coffee. So maybe a cup of coffee is a task from ActionNet or from alpha dataset. So this task is being deployed into the real world. So I think this is a more of a very cool example to see how embodied AI learning might have a potential in terms of going into the real world and what it will look like in the real world context.
Okay, maybe we'll take one last question if there's any. Any other questions, friends? Okay, I think we have no further question. Yeah, and thank you so much,
Sure.
Jiafei, for coming. And we can call it an end for the sharing session.
Okay, thank you, everyone.
Okay,
yeah,
thank you.
If anyone has any other question, feel free to email me. Yeah, thanks. Bye.
Okay, bye-bye.